Hi, Assalamualaikum warahmatullahi wabarakatuh. And we are from class E. Here is the video for assessment second week. Myself is Izatul Aida Binti Suhaimi. The first question will be answered by Mohamad Nabil Zulkarnain. The second question will be discussed by Ahmad Nubli bin Yatiman. The third question will be explained by Muhammad Azfar Zharif. And the last question will be discussed by Muhammad Khairul Iman. Okay, for example, during construction, steel reinforcement bar alone won't be sufficient to cater tensile strength. So the solution taken is pre-stressed concrete is being used. During pre-stressing, the tendon will be stretched along the axis and the cement is poured. When the cement hardens, the tendon is released. The compression will be generated at the bottom. This will balance the stress imposed in the member during the service.
Assalamualaikum warahmatullahi wabarakatuh. I'm Mohamad Nabil and I will explain about reinforced concrete, pre-stressed concrete, with its concept and principle. So what is reinforced concrete? Reinforced concrete is combination of two elements, which is concrete and steel. Concrete is strong in resisting compression and weak in tension, while steel is strong in resisting tension. Therefore, reinforced concrete was used to resist both compression and tension. So let's go to pre-stressed concrete. Pre-stressed concrete is developed by produce internal stress to counteract the external stress. By this action, it will increase the strength of concrete. So let's proceed to concept of pre-stressing. Pre-stressing is application of an initial load on the concrete structure so that the structure is able to counteract or withstand the stress coming due to surface load. The concept of pre-stressing was invented a few decades ago when metal bands were wound around wooden pieces to form barrels. The metal bands were tightened under tensile stress, which create compression between the staves, allowing them to resist internal liquid pressure. Okay, let's proceed to the principle of pre-stressing. Pre-stressing is a method which compression force is applied to reinforce concrete section. The effect of pre-stressing is to reduce the tensile stress in the section to the point until the tensile stress is below the cracking stress. Thus, the concrete will do not crack. The concrete can be visualized to have two compressive force, which is internal pre-stressing force and external force. These two forces must counteract each other to make sure the principle of pre-stressed concrete is applied in the concrete. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nubli bin Yatiman. Okay, for the pre-stressed concrete, there are two processes in pre-stressed concrete, which are pre-tensioning and post-tensioning. Pre-tensioning is a pre-stressed concrete that tendons are tensioned before concrete is poured, while post-tensioning, tendons are tensioned after concrete is poured. Okay, now let's go to the video.
We're here today. We're actually starting to stress our post-tension deck here at St. Augustine, Platteville. and I'll talk a little bit about this process. So it just looks like plain concrete to most people, but there's actually 10-foot cavity underneath here where there'll eventually be parking. And so what we do is we come in and we put shoring underneath here with beams, shores, plywood this, and then on Wednesday we poured concrete on here, 14-inch deck. I think it came to about 350 yards, and then essentially then it's just a waiting game because we have to wait until the concrete can reach a certain pressure, and then we pull the cables. Concrete inherently is very weak in a tension situation, but has very high compression properties. So we run these cables through here per the engineer's design, and that allows the building to actually carry on the columns and the outside walls. And so we poured Wednesday, and then we have these small cylinders. We have to reach 3,000 pounds on those cylinders for safety, because when they pull those cables, they put 33,000 pounds on the cable head. So anything less than that will actually fracture the concrete. And so right now they're just working on, they'll go through and stress all these, then we can pull down our shoring, and we'll have a beautiful concrete deck that we can frame off of.
Okay, the video is about post-tensioning concrete slab. This is a few steps for the post-tensioning concrete slab. Which is firstly is installing shoring or side formwork for post-tension slab. Then place a reinforcing steel bar, which is lower reinforcing steel bar, which is BRC. Then step 3 is lay the tendon for the tensioning purpose. And step 4, set up the anchorage. Step 5, place top reinforcing steel bar. Then pour the concrete. After pour the concrete need to be waiting until it achieves specific strength before stressing the tendon. The tendon is stressing by the huge machine, which is hydraulic jack, in the side of the tendon. Okay, after finish the stressing the tendon, then disassemble the shoring or formwork. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for the number 3, I will discuss about the facts why precast concrete is preferred compared to conventional in situ construction method. And in my slide, I have precast concrete compared to conventional in situ construction. Then there is characteristic that I will compare as a casting, quality control, cost, worker, strength concrete, and time taken. For casting, as we know, precast concrete have easier to control the mix, placement, and curing. The weather has no impact on casting work, even if raining seasons. For conventional in situ construction, for casting, it's difficult to control the mix, placement, and curing. The weather will impact the casting work because they casting the concrete at the site. For quality control, for precast concrete, it can be controlled and maintained easily. But for conventional in situ construction, it is very hard to maintain and is very hard to control. In the term of cost, precast concrete have the cheaper form of construction if large structures are to be constructed. Why? In conventional in situ construction, it is very expensive for large structures. In terms of worker, precast concrete does not need more labours, so less labours are required at construction site. Why? In situ construction, need more labours required inside to handle concreting, modelling, and another else. In terms of strength concrete, in precast concrete, it can increase in strength by achieve the accelerate curing. While in conventional in situ construction, it find difficult tasks. It need to do difficult tasks to increase the strength. For time taken, precast concrete, it will reduce the total construction time and does not affect by the weather. Why? Because in situ construction, when raining, they need to stop, while precast have complete their and water taken for construction in situ construction is total construction time is more and can get delayed if the weather is not good. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Khairul Iman Bakhori. Now, I will go through to the question number 4, which is how precast concrete can contribute towards reducing carbon dioxide and global warming. Firstly, I will explain what is the carbon dioxide and global warming. As we know, carbon dioxide is a greenhouse gas. What is the greenhouse gas? Greenhouse gas is a gas that contributes to the greenhouse effects by absorbing infrared radiation. Next, concrete is a major contributor to the climate crisis because its production releases huge quantity of carbon dioxide into the atmosphere. As we know, the concrete consists of 3 elements, which is cement, water, and aggregate. The huge problem here are cement production is a highly energy intensive production process. According to Ernst Worrell 2001, in his journal, he said energy consumption by the cement industry is estimated at about 2% of the global primary energy consumption, or almost 5% of the total global industrial energy consumption. Because of dominant use of carbon-intensive fuels, such as coal in clinker making, the cement industry is a major source of carbon dioxide emission. Next, we know the increasing emission of carbon dioxide into atmosphere can lead increasing in global warming. Next, I want to tell you about the previous study that handled by Yahundong. According to research made by Yahundong 2015, the title is Comparing Carbon Emission of Precast and Cast in Situ Construction Methods, a case study of high-rise private building. In his study, the study was made at small size of construction site in Hong Kong. Used precast concrete has been frequently adopted. The study is compare the carbon emissions of precast and traditional cast in situ construction method based on a case study of a private residential building in Hong Kong. The result of his research, it is found that the carbon emission of the study residential apartment is 669 kilogram carbon dioxide equivalent per 1 square meter floor area. Precasting can lead to 10% carbon reduction for 1 cubic meter concrete. Steel formwork for precasting perform better than timber formwork used in cast in situ concrete. By adopting more precast concrete can lead to less carbon emission. This is from research Yahundong on 2015. Now I will explain how precast concrete can reduce carbon dioxide and global warming issues. Precast concrete production is done off the construction site. In climate control factory conditions. In climate control factory conditions where critical factors like temperature and humidity are tightly regulated. Next, precast concrete in particular is even stronger because it manufactured in a controlled environment with a more exact mixing, molding, and curing process. Next, precast eco-friendly characteristic. Globally, efficient use of energy is the key in limiting the impact of climate change. And lastly, in many climates, precast component thermal mass enable building to consume less energy by reducing the needs for heating and cooling. This slow absorption and release of heat, especially when combined with insulation, helps to avoid the emissions associated with the electricity generation of burning of natural gas required to heat and cool a building. As a conclusion, based on the research finding, it is highly recommended to adopt precast concrete in a building construction. The building industry should consider the carbon reduction as a benefit of implementing precast concrete. Thank you.